In this video, we wanted to talk about the basics of queue in an RTOS. Um, with FreeRTOS as an example, you start off with the FreeRTOS.h include and queue.h include. The first thing you want is to have a queue handle because you can have multiple queues, right? So let's have a queue handle, and we'll call it queue handle of ints. Now, just declaring this queue handle doesn't create the queue. So the first step is you want to be able to create the queue by using xQCreate API in FreeRTOS. This API's first parameter is the length of the queue, which is how deep, how many items would you like to have in this queue. So let's say we want a queue of 3 integers. And the second parameter is what is the size of one item. So we will do size of int. Now we created a queue. FreeRTOS will internally allocate memory for the queue data structure, as well as a queue that can absorb 3 integers in this case. So this single function call will allocate all the memory it needs for this queue, which is namely, first one is the data structure itself, and the second one is the memory for the queue. So now you have a queue of integers, and because we're using C language, we got to be careful that this queue handle is only used for integers. So in the producer, let's just have an item that starts with 0, item increments, and then we're going to do xq send. The producer is going to send data to this queue, and we're going to say, where do you want to copy the item from? So it's going to be address of item. How long do you want to wait for the item to be sent if the queue is full? Now we're going to set up this skeleton of the program where the queue doesn't really become full. So I used a timeout value 0. We're going to make more videos to explain that parameter. For now, this video is just going to focus on super basics of how to create a queue and how to pass data in between queues. So you have a producer already set up here. Producer is a function that produces one item per second, because in FreeRTOS we set up ticks to equals milliseconds. And we're going to catch that item in the consumer side. So I'm going to have, int item, best practice, just always initialize to 0. And I'm going to do queue receive. Which queue do you want to receive it from? So that's this guy. Where do you want to copy the data to? So that's address of item. How long do you want to wait for an item to be available? In this case, I'm going to use max delay, which is infinity. So this is basically saying, wait forever until we can get an item available in the queue. If there is no item in the queue, then we keep on waiting forever. So that's the logic here. So because of that, I don't need, because I'm going to wait for an item indefinitely, I don't need a, task sleep in this consumer task. And in this case, I'm just going to say, received this item. So now let's go ahead and run this program. Exactly what I'm using to compile this program, that's a little bit outside of the scope. That's yet another video we'll create for you. So what I'm going to do is go ahead and build this project, or solve some compiler errors. Let's try this. Errors and warnings, that is. Okay, so we compile without a warning. I'm going to run this program, and we're going to observe the output. So here we have a very simple program where you created a queue, in this case, a queue of 3 items, and each item is the size of integer. Based on the way I've set up this program, even one item will be sufficient, because the producer produces one item per second, and the consumer catches it as immediately as soon as the item is available, and it will say receive. So I'm using a queue of 1, so it's not really a queue in a way. But what it demonstrates is the basics of using an RTOS queue, and it can be any RTOS, not just FreeRTOS in particular, because all queues in all RTOSes behave the same way. So as I mentioned, we have a queue of 1, and I'm able to send data from one task to another task, which is a fundamental thing that you can do in any RTOS. Let's do one more thing before we wrap up this short video. I'm going to create a queue of 2 items. And then I'm going to send an item twice. So this will demonstrate that the queue can absorb 2 items as long as its size is 2. And now we'll say, the consumer is saying received 1s, received 2s, received 3s, and so forth. Of course, if the queue can only absorb 1 item, right now the way the program is structured is one of your items will be dropped. As you see, we have like the old output where it's receiving 1, 2, 3, 4, but the duplicate item, this is being dropped. So let's summarize the short video. So with FreeRTOS queues, you have to have a queue handle. After you declare a queue handle, right? So this is merely declaring it. The second step or second immediate step after that should be you want to create that queue. So queue of integers equals xqueue create. How many items can the queue absorb in one time? What is the size of each item? You can then use xqueue send using that queue handle, and data in RTOS API is always received to and from using address. So you want to say send an item from this address, send an item from this address, and likewise receive from this queue an item and copy the data to this address. In other words, this is not a zero copy queue. This is your items are copied out of the queue into your local variable. So let's wrap it up here because there's so many advanced cases of queues we can cover. And we'll break it up into smaller videos for you guys.